So, our final talk of the day is presented by Magic Sendlak from the University of, I'm not going to try and pronounce that town. Okay. And he's going to give us a note on counterpossibles and similarity. Take it away.
Okay, thank you very much. So, the subject of my presentation is the notion of similarity, which is like the crucial notion when it comes to possible worlds, semantics, analysis of counterfactuals, and especially counterpossibles, which are basically counterfactuals with an impossible antecedent. So I have two theses, the negative thesis and the positive thesis. The negative thesis is that the standard notion of similarity implies some quite problematic and, I believe, counterintuitive consequence. And the positive thesis is that I would like to present a sketch of modified notion which is supposed to deal with this counterintuition consequences. Okay, so this is the plan. Firstly, I will say something about counterpossibles in general and what is the well-accepted analysis of counterfactuals with impossible antecedents. Then I will say something about this special case of impossible world, which is the trivial world, the one where everything is true. And in order to deliver this modified notion of similarity, I will introduce two types of worlds, which are supposed to be helpful. Okay, so the counterpossibles are just sentences, are just counterfactuals, which are basically expresses as if phi then psi, such as if today it wouldn't be raining, then it would be better for all of us, right? Something like that. So the counterpossibles are just like these counterfactuals, but the antecedents express impossibility. So the claim which is necessarily false, or in other words, the claim which is false in every possible world. So there is no possible world where this phi is true. So example of these are okay. So the first one says that if nominalism were true, then there would be no mathematical objects. And I mean, I have nothing against nominalism, right? But from, let's say, realistic point of view, nominalism is necessarily false, right? But it's if one is nominalist, then can just switch example and says if Platonism were true, then there would be a lot of mathematical objects, right? The second one is so the first one is metaphysically impossible. The second one is mathematically impossible. Namely, if 10 were a prime number, then there would be at least one prime number that had 2 as a factor. And the third one is logically impossible. Namely, if there were a true contradiction, then classical logicians would not be amazed, right? So, as you can see, the first two seems to be true, right? But the last one, not really, right? Probably.
It used to be. Yeah, I'm never amazed.
Okay, so the problem is that according to the standard analysis of counterfactuals, all of these are true. These are trivially true, let's say. Because according to the standard analysis of counterfactuals without impossible worlds, it is claimed that the counterfactual is true, among others, when the antecedence is false. So where there is no world where antecedence is true. So all of them are simply true, right? So it's something that we rather do not like to accept, because we can just make some non-trivial inferences based on what is impossible, right? What we take to be impossible. So in order to deal with this kind of counterfactuals, some philosophers have been arguing that we should introduce impossible worlds to our semantic or ontology or whatever. So the claim is that just like for every possibility there is a world where this possibility is actual, let's say. So for every impossibility there is an impossible world which belongs to different space of worlds and which represent what is impossible in the actual world. So we have a impossible world where nominalism were true, and where 10 is a prime number, and where there are true contradictions, right? The second claim is that some impossible worlds are more similar to the actual than others, right? It's quite simple, let's say. I mean, the world where, for example, okay, I will give an example later. And the criteria for true value of counterpossibles is that if phi then psi is true in the actual world, if world W1 where phi and psi are true is more similar to the actual world than the world W2 where phi is true but psi is false. So we have two worlds, and in fact 3 worlds. We have the actual world, the world W1, where it is the case that phi is psi, and we have world W2 where it is the case that phi, but it's not the case that psi. And if W2 is closer to the actual world, or is more similar to the actual world than W2, then this counterfactual is simply true. Okay, but the most important is how to understand what does it mean that something is more similar, that one world is more similar to the actual world than others. So there are some claims about the similarity between the actual and the impossible worlds. So the first one, I call it standard notion of similarity because it's accepted by probably all of philosophers who accept impossible worlds and who would like to give an analysis of counterpossibles in terms of impossible world. So okay, so this is the quote from Francesco Berto, and he says something like that. It's intuitive to claim that some impossible worlds are more similar to the actual world than others. For instance, explosion world, call it E, at which everything is the case, that is, at which every sentence is true, seems to be as far from the actual world as one can imagine, provided one can actually imagine or conceive such an extremely absurd situation. Now pick the impossible world T, at which everything is as in the actual world, except that I wear an impossible t-shirt which is white all over and black all over. Intuitively, T is closer to the actual world than E. So it seems that the world where, let's say, just one contradiction is true is more similar to the actual world than where plenty of contradictions are true, right? Because it seems that these worlds, I mean, the world T has more common with the actual world than world E, or any other world where there are more than just one contradiction. Okay, so the second claim is that any possible world is closer to the actual world than any impossible one is. It's called the strangest of impossibility condition, and it comes from Daniel Nolan. So, I would like to discuss these two claims and show that they are false. I mean, it seems to me that they are false, and I would like to present some arguments. And in order to do that, I will start with the case of the trivial world. That's mean this E world, right? The world where everything is the case. So, as Berto said, the explosion world at which everything is the case, that is, at which every sentence is true, seems to be as far from the actual world as one can imagine. So every world is closer to the actual world than the trivial world is. Now consider two counterpossibles. if there were a true contradiction, then everything would be true. And the second one, if there were a true contradiction, then still not everything would be true. The world W2 is a world where contradiction is true, but not everything is true. The world W1 is the trivial world. Everything is true in the world W1. So if we add to this the claim that the trivial world is the most similar to the actual world, and also we take this criteria for truth of counterfactuals, we have to admit that the rule of explosion is false in the actual world, right? Because the sentence number 2 is true and not the sentence number 1, since this world is closer to the actual world than the world W1. So, of course, there are some philosophers who would like to say, yeah, that's how it goes. I mean, especially if they're into paraconsistent logic or something like that. So it's okay with them, but there are lots of philosophers who would like to give an analysis of counterpossibles without rejection the rule of explosion in the actual world, and it seems to me like it's a good idea. I mean, it's worth trying, let's say. So my aim is to say something about similarity, namely to sketch the notion of similarity, which allows us to save the rule of explosion in the actual world, and on the other hand, will give us some explanation why we take some of counterpossibles as true and some of them as false. So, in order to, okay, so this problem, I mean, the claim that the rule of explosion is false in the actual world is based on 3 assumptions, let's say. Namely, that for every impossibility there is a world which represents this impossibility, and that some impossible worlds are more similar to the actual than others, and that the trivial world is the most dissimilar to the actual world. So it seems to me that to save the rule of explosion in the actual world, we have to reject one of these. And it's hard to reject the first one, since it's, I mean, this is like the main claim of impossible worlds, right? That for every impossibility there is a world which represents this impossibility. And similar with the second one, if we reject the claim that some worlds are more similar to the actual world than others are, then we have to admit that every counterpossibles have the same true value, and it's surely not what we are looking for. So it seems to me that what we have to do is just to reject the third one, but I'm not really sure, so I put a question mark on it. So in order to do that, I introduced two kinds of worlds, and in order to say what is the difference between organized and chaotic worlds, let me just give you an example, a question, let's say. Imagine that someone asks you to finish this sentence, right? If 2 plus 2 equals 8, and 2 plus 3 equals 10, and 2 plus 4 equals 12, then 2 plus 5 equals... Anyone?
42.
42. No, not really. 14. Yes, 14. Okay. There are no rewards, but okay. So, and let's say that these facts are true in the world W3, right? There is a case that I mean, it's true in the world W3. Now, take another. Of course, it's counterpossibles, right? Because it's necessarily false in the actual world that 2 plus 2 equals 8 and so on. So now take another one. If 2 plus 2 equals 8, and 2 plus 3 equals 10, and 2 plus 4 equals 12, then 2 plus 5 equals 7. So at W4, it is true that 2 plus 5 equals 7. So it seems that, I mean, it's impossible, right? So there's a world where it's true. So, so we have two worlds, W3 and W4, and you can see W4 has more common with the actual world than world W3. So it seems that according to these two claims that I presented earlier, we should claim that sentence number 2 is true and not sentence number 1, right? And it's like, as some of you answered, we really like to, I mean, if you assume this antecedents, we would like to say that 2 plus 5 equals 14. It's like, that's how we are reasoning, right? That's how our inferences work. Okay, so it seems that this is the one, this is the one example of, this is the one of reason why it's good to reject this claim that we should measure similarity between worlds basing on common facts, let's say, between worlds, right? Because if not, then this world is more similar to the actual world, so this claim is true and not the other one. Okay, so this was an example with mathematical impossibilities. Now let's skip to metaphysical impossibilities. Let's say that we are essentialists and we are believing that every object has an individual essence and properties. So the world W5 is an impossible world, right? It's a world where no essence exists, let's say. Every object is just a bundle of properties. So it's impossible world. Now consider the second world, where almost every object has an individual essence and properties, so just very similar to the actual world. The only example is the oldest Galapagos turtle, which has no essence and is just a bundle of properties, whatever that means. And so, again, it seems that W6 is more similar to the actual world than W5, because if we assume that we are essentialists, then we would like to claim that, in fact, this object has an essence, this, and so on and so on, right? So, but now consider these two counterpossibles. If the essentialities were false, the non-object would have an essence. This corresponds to W5. The second, if the essentialities were false, then there would be only one object without an individual essence. And it seems to be false, right? Because then non-object would have an individual essence, it seems to be. So, once again, the world which in fact has less common with the actual world seems to be closer. So this is like, well, it's just another example of why we shouldn't treat similarity as, why we shouldn't measure similarity basing on similar facts between worlds. Okay, so now what is significant, or what is the most important feature of the world W3 and W5, right? What makes them more similar to the actual world than worlds W6 and W4? Well, it seems to me that this feature is that these are consistent worlds, let's say. And by consistent, I don't mean that there are no contradictions in there, because even paraconsistent world is consistent as well as it acts accordingly to paraconsistent logic, right? But I mean that they are organized in some way, right? That we can point on some regularities that obtain in these worlds. That these worlds act accordingly to some regularities. And it seems to me that this is like the crucial point for why we are treating W3 and W5 as closer to the actual world than worlds W4 and 6. Okay, so now what about the trivial world, right? The world that that I've started with. Okay, universe of worlds might be divided into two sets, possible worlds and impossible worlds. And for all I said, impossible worlds are divided into organized and chaotic worlds, right? So what about the trivial world? Whether is it chaotic or organized? Well, if W1 and W2 are worlds where classical logic is true and where contradiction is true as well, right? But the difference is that W1 acts accordingly to this assumption and leads to truthfulness of every sentence, whereas W2 ignores this, the rule of explosion. So W1, although it is trivial world where everything is true, it's just act accordingly to what is true in this world, let's say. So it seems to me that after all, the trivial world is more similar to the actual world because of these regularities than the world W2. Well, one might say, why do you believe that the world where classical logic is true and where contradictions are true is organized world? After all, these are so inconsistent claims that it's hard to find more inconsistent claims than these two. Well, of course they are inconsistent. That's why this is impossible world and not a possible world, right? If we assume that, I mean, if for every impossibility there is a world which represents it, so there is also a world where contradictions are true and where classical logic is true. And obviously it's a world where everything is true, right? Okay, so one might ask, are there also organized and chaotic possible worlds? Can we just draw a similar distinction in a possible worlds? Well, it seems to me that, yeah, why not? Let's assume that the possible worlds W1 where water boils in 15 degrees, right? It's possible. Logically, it's possible that, I mean, there's a world where water boils in 50 degrees. Now, let's take another world where water boils in 50 degrees, except Berlin where water boils in 100 degrees. It's also logically possible world, right? There's no contradictions in it. So, once again, if we measure similarity based on number of facts, we had to claim that world W2 is closer to the actual world, because in the actual world, in Berlin, water boils in 100 degrees. But then we have these two counterfactuals. If the water in Ghent would boil at 50 degrees, then it would also boil at 50 degrees in Berlin. And the second one, if the water in Ghent would boil at 50 degrees, then it would boil at 100 degrees in Berlin. So once again, it seems that we rather like to admit that this claim, this sentence is true and not this. Why? Because we can point on some regularities in this world, right? And when we are using, I mean, if we are using counterfactuals and counterpossibles to make some non-trivial inferences, it seems to me that the basic, the most important feature of this world is that they are organized in understandable way, let's say, for us. Okay, so of course we have organized and chaotic worlds, and it seems to me that it's non-controversial to assume that the actual world is one of organized world. Of course, it's not the only one, because there is also this world where water boils in 50 degrees. So this allows to reject this claim that any possible world, however weird, should be closer to the actual world than any impossible world. Well, it seems to me that it should be this kind of principle, that any organized world, however weird, should be closer to the actual than any chaotic world is. Right? I call it strangeness of chaos condition after Nolan. I mean, paraphrase Nolan. So one might say, well, it's a little bit crazy, because we have strong intuition that what is possible is way more similar to the actual world than what is impossible. So every possible world is more similar to the actual world than any possible. But it seems to me that it's quite important to notice that being similar, that there is no such a thing as being similar in general. There is rather being similar in respect of some features, right? So if we have, let's say, if you have three objects, orange, ball, and a letter, and I will ask you what is more similar to the ball. Probably most of you will say, well, of course, orange, right? It's round and so on. But if I ask you what is more similar to the ball in virtue of being non-organic object, then surely it would not be orange but rather a letter, right? It's quite trivial but quite important, it seems to me. So the important thing is to find what is the crucial feature of worlds which we should take to be the thing thanks to which we measure similarity between worlds. So my modified notion of similarity is very similar to this standard notion, because these first two claims are just the same. The difference is in the third claim, namely that every organized world is more similar to the actual world than any chaotic world is. So, of course, we have to reject. I mean, if someone accepts this, then we have to reject these two claims, namely that the trivial world is the most dissimilar, and the second one that every possible world is more similar than any impossible world is. But it seems to me that if we want to use counterfactuals and counterpossibles to explain why if we would like to use possible and impossible framework to explain why some of counterfactuals are true and some of them are false, it seems to me that the feature or the property of being organized is quite good. And I mean, maybe not the best, but better than the standard one. Okay, thank you.
Okay, so now we'll have two commentaries. First one from Clayton Peterson.
Well, thanks for the talk. I'll be quite brief, actually, and I have one remark regarding the standard notion of similarity and your third proposition that the trivial world is the most dissimilar to the actual. So I'll have a small example. So in the standard notion of similarity seems to be understood as follows. So the similarity of an impossible world depends on the number of true sentences it shares with the actual world, and a world where there are, well, more contradiction is more dissimilar to our world than another where there are less contradiction, right? So in this respect, two worlds can be compared by counting their similarities and their differences, right? So now, so take the actual world to be phi1 to phi n sentences. Now you have the explosion world, which is actually the set of well-formed formulas of your language, right? It has everything. So now, consider the famous less trivial world. In your notation it was T, which is the explosion without, say, psi and not psi. Okay? So now number of similarities with respect to actual world and the number of differences with respect to the actual world. So we have the explosion world and T, which is explosion without this. So there will be actually n similarities in both cases.
Well, but sorry,
And
T is not explosion without one contradiction. It's just actual world with one.
okay, but take T prime.
Oh, okay.
Okay. So both are denumerable, right? So the number of differences is actually the same. And so you cannot say that the trivial world is the most dissimilar if you compare similarities and differences by counting and stuff. And just to pursue this analogy, consider the logical consequences of the actual world. So you'll still have n similarities and a denumerable number of differences. And, well, so in this respect, the set of logical consequence of the actual world is as similar and as dissimilar to the explosion world if we define similarity in terms of counting similarities and differences. So that's pretty much all I have to say.
Okay, so thanks. The thing is that there's a lot of more or less vague intuitions about similarities in works of philosophers of impossible worlds, and in fact there is. I couldn't find some well-formed, let's say, notion of similarity. And it seems to me like, just like I said, we have a lot of different vague intuitions. So what I called the standard notion of similarity, it was based on these two claims, one from Bertov and the other one from Noah. And it seems to me that these claims are shared among every theorist of impossible worlds who deals with counterpossibles. And I mean, if this is okay, then it's even better for me, right? It's not good for them, right? But as I said, I mean, I can just thank you for another argument. It's just understanding similarity. Oh.
All right, thank you. And here's another one.
So I also have some vague intuitions about similarity, and my vague intuition is that similarity should work as a distance. And I think this intuition is pretty common and is captured in the idea of spheres, which have been used in history by Lewis to evaluate counterfactuals. And what I'm going to do is I will draw some picture which I think would help to clarify the relation between the standard notion of similarity for impossible worlds and your modified one. And if I will still have some time, I will add a very good intuition and draw another picture. Okay, so I guess here's the Lewisian idea. I'm picking the actual world W, and then I draw sort of sphere-like things, and the longer this line is, the farther the. So and then I pick some points in here, and the longer the line, the longer the distance. Okay, and I guess it works just fine for possible worlds, which I will note by P. Then I think, and when we add impossible worlds to the picture, it's not so clear how should we draw it. Right. they had the idea that all those bad guys are farther away from.
Yep. Than
Yeah.
the good guys.
So I think the proper picture should be something like this. Here sit the bad guys. That's impossible world. And here we have a very long distance, which should be just long enough so that, you know, if the maximal distance between those two is, say, 1, then L should be, I don't know, 2 maybe, or something like this. Oh, and also there's the trigger word. I'm not sure if it is unique or not, but let's assume it is. So my intuition is that that bastard should sit very far away from here and very far away from here. And actually, I would like to make the distance infinite. But I guess it could be up to debate. The nice thing about putting it to infinity is that it will be farther away from any word than any other one, if it is unique. So I guess
It is.
it's a good thing. Yeah. Okay. Now, so I think that's the standard notion of similarity for impossible words. And if we agree for the distinction between organized and chaotic ones, I think we should just split the bastards into two. So we have possible words in here. Here we have a long distance. Here we have those organized bastards, right? Here we have long distance again. And here we have chaotic bastards. And here at infinity we have the big boss that is trigger word. Does this picture
No, not really.
represent what you mean by modified notion of similarity?
No, not. I mean, the trivial world is closer to. I mean,
No. It's distance from any of those is infinite.
Why?
Because I put it that way by hand.
Oh. Okay.
No, it's okay. So we should talk about it because I have no idea how do these guys who are doing counterfactuals get their distances from. I think no one really knows. So I just assume that some notion of distance is given.
Well, I
And
mean,
then I just put the distance equal infinity by hand. It's not a distance in the usual mathematical sense. So just take the distance function to be integral plus the union with singleton of infinity. So it's okay.
well, but I mean, it's not a modified notion of similarity.
Oh, it's not.
No, not really, because in the trivial world it's.
Oh, right. Okay. So I guess that will be the standard notion of similarity when we divide words into organized and chaotic ones.
Oh,
Would it be?
hard to tell. I mean, they
Okay.
do not accept this.
That's okay, because I have one more picture which comes from the weird intuition. So can I?
Yeah.
This one. The weird intuition is that sometimes you could have the intuition is that this sentence sort of makes sense, and I think it was like this. If we pick actual word to be W, then some very boring words with just one inconsistency are closer to the actual word than some very weird but consistent words. So here we are today. Here we have an impossible word, and it's a very boring one because it's just like ours, except that 16 plus 1 equals 16, only one is in history. Okay, so it's not a big deal. It happens in the Ministry of Science sometimes, right? And here we have a faraway word, which is a very bizarre one. So there, I don't know, pink unicorns. Everyone uses reverse Polish notation, stuff like that. But it's a consistent word. Okay, so this word in which 16 plus 1 could equal 16 only ones, I guess should be closer to this one.
Well, I believe that
So I
that
guess
not.
it's not.
No,
Oh, okay.
because I mean,
Uh-huh.
it seems like this 16 plus 1 equals 16. I mean, this is very similar to this world, but
Yeah, except it has this one additional inconsistency.
yeah, so it's quite similar to this case with T-shirt, right?
Yeah. Uh-huh.
Okay, so it seems to me that if there's a world where contradiction is true,
Uh-huh.
then it's like, I mean, of course we just, switching intuitions, let's say, but
True.
um,
I have a picture for my intuition.
I didn't have for mine, but
Uh-huh.
so if there's a world where contradictions are true, it seems to me that it's supposed to be plenty of these contradictions and not just a single one, right? I mean, because if we need a logic to describe this world, then why there's only one contradiction? It's quite bizarre, I think. It's just like to say, well, there is a world where possible world where I'm the only one guy who has blue T-shirt. It's a little bit weird world, right? It's I mean, of course these are just intuitions, but
Okay. So fine, because it's really helpful. Because I would like to understand whether I could use something like spheres for evaluating counterfactuals with impossible antecedents or consequence. So my weird intuition would give me the following picture. Some impossible words are close to the actual one, closer than some of the usual possible words. That is good, guys. So then I would do it like this. So here I have possible words plus those impossible which are organized. And these guys are allowed to mix. And then I'm taking the principle you put in there that the chaotic words are very far away. They're farther away than.
okay, so but
So then I draw again the distance, those chaotic bastards, and then the boss.
But the trivial world is still organized world. It's a world where contradictions are true and where classical logic is true. So it's
So would you like to put the bastard like in here?
rather in here because it's organized world. So it's
Okay.
it's here.
Okay. And that would so if we draw a picture like that, would it more or less represent what you mean by the modified notion of?
Now it's okay.
Okay.
So every organized world is closer to the actual. Oh, this is trivial one.
That's the trivial one.
Okay. So, the trivial world is here, of course, but it's organized, so it's closer to the actual world than any chaotic world.
Okay, thanks. That's really helpful. I didn't realize that some people might want to put this bastard in there. Thanks.
Yeah.
That's helpful. So yeah, I guess that's all I have.
Okay, thanks.
All right, thank you to the commentators, and now we'll open it up for questions. Okay, many hands. Sally first.
So I was just wondering, it seems to me that you could essentially do this thing by introducing some kind of measure on the sets of propositions or formulas, whatever, which are true in an impossible world, and it's over simplification to just count the number of formulas that agree, but take a measure for the sets, and organizing principles should be part of the sets. Not just simple facts, but organizing principles. If something is just a bunch of properties with no essence, then everything is that counts as a claim. And you put much weight in your measure to such claims. I mean, a different formulation as a mathematician.
Yeah.
Have you thought of that?
really, but yeah, I mean, this is the one point of view of this measuring, but yeah, thank you, I will consider it.
Dietrich?
Thank you for a very clear lecture, but there are a few things that I'm unhappy about. I have four, and they will be very brief. First of all, in the last discussion, you cannot just say once 16 plus 1 equals 16. Once only in history. Because at the moment that you 16 plus 1 be 1, you also have to consider as false the second piano action. So, and a lot of other things. Okay? Well, 17 plus 1 also be, because 17 then equals 16 and so on and so forth. So we have a lot of problems. That was one little thing. Second little thing, I think there is no standard notion of similarity. There has been a discussion between Lewis and Pollock, and I forgot who took exactly what position, but one of them took clearly the position that you cannot compare theoretically, let alone counting. But you cannot even compare theoretically. You cannot use a theoretic comparison of verified formulas to express similarity. This was one of the clear positions in the discussion. Another thing is that I wonder whether your notion of being organized, whether that is so clear. Things can be organized in many ways. So I think it's just as big as similarity. And the final comment is something particular. The people in parapositive logic that defend that express supporting that as a formula should be true in the at the real world. Where people for which the implication is multi-touch, people are relevant positions, priests, and so on. So, of course, yeah, then you can have it there, but that's very different from the discussion you were having.
Okay, so let me start with the third remark. Of course, one could say that, could you turn on this?
It's coming.
Okay. So, when it comes to the difference between organized and chaotic worlds, one can say, of course, that, well, there is a simple rule about W4 which is satisfied in this rule, namely that 2 plus 2 equal 8, 2 plus 3 equal 10, 2 plus 4 equal 12, and 2 plus 5 equal 7. It's a rule, right? Someone might say something like that. It's a rule. And of course, we can put rule on anything, but what is important for me is just to take as organized these worlds, which are ruled by as simple, maybe not as simple, but quite simple rules. And I mean, just like in the actual world, we rather like to take simple theories without exceptions. And
now you suppose that the notion of simplicity is and is unique, but of course that's not the case.
okay, maybe you're right. When it comes to the first remark, well, I mean, it's impossible that 16 plus 1 equals 16, right? And it's impossible that 16 plus 1 equals 1 and whatever. So for each of these claims, there is a world where it is true. And it's mathematically impossible, so we cannot just judge them from the point of view of the mathematics that is true in the actual world.
Yeah, but I was more criticizing you because what I claimed was that you cannot isolate such a fact. A lot of other things have to be false if, or have to be different from piano arithmetic if 16 plus 1 equals 16.
Well, okay, I could take another example where, someone who's using, I don't know, pick your favorite example of inconsistency, which could be local. So go with that one. And a very bizarre way. So I think the example would work essentially the same.
Can we leave this discussion and move on to Yoko's question?
Oh, we also have a question.
Well,
I had the same kind of worry concerning the distinction between organized and chaotic. And it was not clear to me what the criterion should be. It seems for your example with the boiling water at 15 degrees Celsius, you need something where you're relying on something like if a physical property holds in one place, then it also holds in another place. But then if you take sentences like if the Eiffel Tower is in Brussels, then it is in Belgium, and you present that sentence to a layperson, and you also give them the sentence, if the Eiffel Tower is in Brussels, then it is in China, then most laypersons will see a difference between those two sentences. And that will not be captured by your principle. If a certain physical property, there you need geographical relations that are true and that hold in this world. So the same kind of question like Dietrich, what is your criterion? And there are many ways to organize things.
Yeah, so some philosophers are trying to, they're trying to say something about contextual dependency when it comes to counterfactuals as well as counterpossibles, but it seems to me that there are some reason for not going this way, let's say. But yeah, I mean, it's just like work in progress, and I've just wanted to sketch out some stuff, but I don't have any great story. I just wanted to show you that measuring between number of facts, let's say, or number of truths between worlds, it's not the best way to do it, and just to say the rule of explosion in the actual world, because it seems to me like it's quite an important rule, at least for some of us.
Okay, Luke.
Yeah, this just following up on the first point you made here. You know, I was going on the same route, that is this idea that, look, you know, I mean, take the Berlin case, right? It's not just that in Berlin the water boils at 100 degrees. It's like all the laws of nature are being violated there, right? And if you give those laws of nature a lot of weight, then these are very dissimilar worlds, right? But then I was thinking, you know, maybe you could save the act by saying, well, you know, it depends on your conception of laws of nature. And if it's the case that, you know, laws of nature are no facts over and above the facts that are present in the world, yeah, then you don't have to say that, oh, those words are so dissimilar because law of nature violations there. I mean, facts are just, you know, they're just the brute facts, yeah. But if you have different view of what a law of nature is, then of course you're in trouble. So it seems like your dispute here may come down to what you view is the law of nature.
Okay, I mean, I have no great story what is the law of nature, because it's, I mean, the problem is a little bit
Oh, sorry.
a little bit more general, let's say, than just the case of physically possible or physically impossible worlds.
Yeah, but you could do something similar probably for other types of generalizations. You know, whether you want to assign facticity to these generalizations or not.
No.
I mean, the easiest thing to do is just, you know, to kind of ride on the causation debate, right? Because, you know, there you have a model of whether these laws of nature have facticity over and above the brute facts in the world or not. Right? But maybe the same can be done for the other generalizations.
Yeah, okay, thanks.
Rafael?
More of a follow-up to what Clayton had to say. Let's pretend the notion of similarity is philosophically useful. I'll play along. And even if it is, it seems that when it comes to talking about this notion of natural language and counting true sentences is as useless as it gets. To start with, I mean, the example in the actual world has a finite number of sentences, and it's not the case intuitively that if there's only a finite number of sentences, it's decided that the actual world. And then secondly, I don't know, my intuition is that when it comes, again, to describing stuff in natural language, if you cannot just change the value of a finite number of sentences. Any small change will just change, you know, the value of an infinite number of sentences in you know, quite intricate ways. So I'm not sure how important counterexamples that involve counting differences in terms of counting in terms of counting sentences, to an extent they are helpful. But I mean, maybe this is a question for like, I don't know.
Question for me. I don't think we should have
So who does them? Why did we do this?
Why do we count?
No, I mean the example that was discussed in the comments was sort of formulated as if you could establish how similar the worlds are counting sentences, right? Am I wrong?
I'm not sure whether I understood correctly what you said.
Never mind, we'll talk about it.
Are there any, we have time for another short question, very short question. But, is it short?
Sure. There seems to be a tension between two criteria for similarity for countability of true sentences or regularity. Do you assume classical rules in order to regularize the world here? Because think about maybe paradoxes in your or actual world. There are some paradoxes. So do you want to cancel these paradoxes in order to be more regular?
Oh yeah, that's a good question. Well, I mean, we're trying to fight with these paradoxes because we believe that the world is consistent, let's say, right? I mean, or aren't we? I mean, yeah. Just like I said, we like to believe that the actual world is organized world, right? That's why we don't like paradoxes. So,
just think about paradoxal logic. For me, paradoxal logic is more intuitive, so to say, because triviality explosion is very counterintuitive. If you want to emphasize about intuitivity of logical rules, so there's something like a tension between intuitivity and rationality. How to make a decision?
I don't know right now. Sorry.
All right, so thank the speaker again. Now, before everyone takes off,